so before we get into asking these questions that we're asking, let's first talk a little bit about what a coterminal angle is again, and what a reference angle is again, and why there's such a big deal about them. Okay? All right? So, let's do coterminal first. This is from Friday. We talked about on Friday. Okay? What is the definition of a coterminal angle? Or what's the definition of two coterminal angles, I should say. It's a plural type of thing. What does it mean to be coterminal?
With the same initial and terminal side, but has a different measure.
So, really, it's just the same terminal side. Yep. But they have two different measures, right? So, like, I think we used 30 in my classes on Friday. I think we used 30 and then like negative 330. Okay. Same terminal sides, different measures. Okay. All right. So that's coterminal. How do we get the different coterminal angles? Or how do we find, using maths, the different coterminal angles? Add 360, we go around another loop, right? Okay. Or 2 pi, or subtract 360, or subtract 2 pi. Yep. Okay. So we either add 360 degrees if we're getting to more positive and positive ones, or we subtract 360 to get more negative ones. Okay. Or 2 pi. Won't distract you. Okay? Alright, so that's coterminal. Reference. Okay? So reference angles are the acute angles formed by the terminal side of theta and the horizontal. Always by the horizontal. Never off the vertical, always off the horizontal. Why are reference angles important? Why are they important? Meaning, what's the deal? What's the big deal about reference angles? Why are reference angles so important?
Does it have to do with like if like an angle was put in like a weird situation that wasn't like on the grid, if they have like so if like I had a 30-degree angle hanging from like the ceiling, it'd be a 30-degree angle, not like a weird number that people don't like understand. I don't know where I was going.
Not really. No. I mean that's part of it, yeah, but that's not the big major reason why we always go with the reference angle. Why do we go with reference angles? Why do we use reference angles? What do we use reference, or like on Friday, what did we use reference angles for? Other than just finding what they are. Like that one, you mean?
Yeah, like that problem. We were using the silent triangle to find the measure of theta.
To find the angle, right? Okay. And so why was it important for us to use reference angles in this problem? I'll take you back even longer than last Friday. I'll take you back to when you were in geometry. What's the only way that you know of to find an angle? Inverse trig functions, right? Okay. And so we have to use inverse trig functions to find angles. So then why is reference angle so important if I'm using inverse cosine to find the angles? Why is reference angles so darn important? And why is an acute angle so important?
Because that's the only function that can be output by like a calculator by trig functions. It can't go more than 180.
Not even so much the calculator. It's the trig function aspect of it, right? Okay? Because what are we, in order to use sine, cosine, and tangent, what do I need? What kind of a figure do I need? Even more. Not just a triangle. I need a right triangle. Okay? And in a right triangle, I've got a right angle, correct? And what? Two acute angles. Okay? So reference angles are important because they're always acute. It allows me to make a right triangle based upon what point I go through, which allows me to use right triangle trig to find the angle, or the reference angle, which then allows me to find the actual angle. Okay? So reference angles are important. They allow us to work off of prior knowledge to get what we want, okay? To find the things that we need. Okay? All right? So, what I would like to do on this slide now is I would like to find us a reference angle, 1, and 2, I would also like to find a positive and negative coterminal angle with the theta that is given. Okay? So, and again, this is just me, I'm an old curmudgeon, okay, and I'm kind of set in my ways, because that's what old curmudgeons do. Okay, they, get off my lawn, kind of a deal. I'm not that guy. But anyways, okay. So I always draw myself a picture as to where theta is, okay, because that helps me figure it out. Oh, hey now. So I always start with a grid. Okay. Negative 150 degrees would be down here. Reference angles always come off of the horizontal, not the y-axis. No, the x-axis. Always come off the x-axis. Oh, okay. Yep. Okay. So theta prime is in there, right? Okay. So how many degrees do I need to get back to that horizontal? I need 30 degrees. So my reference angle here is 30 degrees. Okay. If I would like to come up with some coterminal angles, I can add 360 to negative 150, right? Puts me in the exact same spot. So if I add that to it, I would get 210 degrees. Yes? If I went around another one, I would be 570 degrees. If I went around another one, that would be 930 degrees, and so on and so forth. Right? if I take negative 150 degrees and I subtract off 360 degrees, I'm at negative 510. If I subtract off another loop, that's negative 870 degrees. If I subtract off another loop, that's negative 1230 degrees. And so on and so forth. Okay. 70 degrees. What's the reference angle to go along with an angle of 70 degrees? Lucas? 70. Because it's in quadrant 1, it's its own reference angle, right? Yeah. Coterminals. Add 360, 430, right? Yep. Okay. Subtract 360, negative 290. Yes, son? Love it. Love it. That's love at 425 degrees. One more. What I would like you to do now is I would like you to do the same. Find me the reference angle, find me a positive and a negative coterminal angle to go along with numbers 8 and 9.
Do we need to memorize what the 2 pi over 3 is? Or do we get
That's why you're using your unit circle. Yep.
for the test?
So 2 pi over 3 is up here. I need to get my reference angle is here then. Always again comes off of the horizontal. So pi, since we're dealing with radians, rule of thumb, when you're for lack of a better term, the terms of the problem or the given information in the problem is in a specific radians or degrees, stay in radians or degrees. You know what I mean? So like this problem was given to us in radians, we're going to stay in radians throughout this whole problem. Okay? If it was in degrees like the other two that we just did, then we'll stay in degrees. But so whatever it's in, stay in that. Okay? So I need to get to pi. This down over here is pi, so I need to get to that. So that's 3 pi over 3. So that means my reference angle is pi over 3. Okay. Coterminal angles. A coterminal angle with that. So now again, I'm not thinking about adding 360 degrees to it because I'm in radians, so I'm thinking about adding 2 pi to go around either direction, right? But because I'm dealing with thirds, I'm actually thinking about 2 pi as 6 pi over 3. So if I add 6 pi over 3 to 2 pi over 3, that gives me 8 pi over 3 as the next coterminal angle on the positive side. 14 pi over 3, 20 pi over 3, 26 pi over 3, 32 pi over 3. All of those are coterminal with that one. Okay? Subtracting 6 pi over 3 gets me negative 4 pi over 3. Negative 10 pi over 3. Negative 16 pi over 3. Negative 22 pi over 3. Negative 28 pi over 3. All of those are coterminals with it. Just depends on how many loops you want to go around. Okay. 7 pi over 4 is down here. Which puts my theta prime here, my reference angle there. Okay. 7 pi over 4, I need to get to 2 pi. 2 pi is 8 pi over 4, so I need to get 1 more pi over 4. So my reference angle here then is pi over 4. Coterminal angles. Again, so now I'm thinking I got to add 2 pi to go around to get to the next one. But instead of thinking about it as 2 pi, I'm thinking about it as 8 pi over 4. So 7 pi over 4 plus 8 pi over 4 is 15 pi over 4. 23 pi over 4. 31 pi over 4. 39 pi over 4. Okay, all of those are coterminal with 7 pi over 4. I can also be subtracting 2 pi, which would take me to negative pi over 4, negative 9 pi over 4, negative 17 pi over 4, negative 25 pi over 4, etc., etc., etc. Okay? So all of those going around that way. Okay? So, theta is in standard position. Refresh my memory. What does it mean to be in standard position?
It's at 0, 0.
What's at 0, 0?
The vertex.
The vertex of my angle is at the origin. Love it. Was there another condition to being in the standard position?
The initial side is on the positive x-axis.
Positive x-axis is the initial side. Okay? All right, so the positive x-axis. Okay? So that means that my initial side is straight out to the right. Love it. Okay? All right. I go through the point negative 5, 12. Okay? So theta is in standard position with the terminal side of theta through this point. So my point is going through negative 5, 12, which is up here. So here is my theta. Agree? We want to find the sine, the cosine, the tangent, all of theta, and we want to find theta. Okay? Well, like we talked about before, we have to use reference angles here. So my theta prime is going to be there. So if I take that triangle and I break it out, theta prime would now be here, and I would have a right triangle. I would have a side length down here of 5 and a side length up here of 12. Okay. Now, notice I dropped the negative sign on the 5 because I'm dealing with a triangle, so I want to think about that as a side length of the triangle and it being positive. Okay. Do I have everything that I need on the triangle, or should I find some more things? Or should I find one more thing? Is this point, negative 5 comma 12, is this point on the unit circle? Wake up. Is this point on the unit circle? Why not? Okay. So why isn't this one on there then? It's past 1 unit. Like it's 5 over and 12 up. Okay. So what is the radius of this circle if I were to make this a circle? 13? How'd you come up with 13? Pythagorean theorem. Okay. All right. So if I call this r to find that radius, okay, I would have 5 squared plus 12 squared equals r squared. 25 plus 144 is 169, which means 13 then is my radius, right? Okay. What's the radius of the unit circle? 1. Okay. Another reason why this point's definitely not on. Okay. Okay. How do I find my reference angle? Let's find that right away, as long as we're in the mode of finding stuff. Now that I found r, do I have to use tangent? I can use any of the 3, right? Okay. So based upon one of your favorite trig functions, find me what the reference angle for theta is. I get a reference angle of 67.380 degrees. Agree? Yes? Okay. All right. So, if that's the case, then what is theta? If my reference angle is 67.38 degrees, and I'm in quadrant number 2, what is my theta?
find 12.62.
Okay. Now on the unit circle, cosine, we have to find sine, cosine, and tangent, right? On the unit circle, the cosine of theta is equal to the x value, correct? Of that particular point. Yes? Okay. Am I on the unit circle? No. But how can I make my circle become the unit circle? How can I make my circle become the unit circle? Unit circles have radiuses of 1, centered at the origin. How can I make my circle become the unit circle? Are they both centered at the origin? Yes, so that part's taken care of. What's the radius of my circle? 13. What's the radius of the unit circle? How can I make 13 become 1? You can divide by 13, right? So whatever on my circle is, I can divide it by 13, and it becomes the unit circle, right? Or I multiply whatever I have in my circle by a scale factor of 1/13, and it shrinks it down to be the unit circle, right? Okay? So, what's the x value of my circle? Or the x coordinate of the point on my circle? -5. I got to divide that by 13, which means the cosine here is -5/13. What's the y value of the point on my circle? So the sine value of my angle then would be 12/13. Logically, in quadrant number 2, do those two values make sense? Is cosine negative in quadrant 2? Is sine positive in quadrant 2? Yes. Okay. All right. In terms of tangent, now, tangent on the unit circle was what? Y over x. Okay. Or, what's another definition of tangent? What's another definition of tangent? Y over x or sine over cosine, right? Okay. Find me the tangent of theta. I got negative 12/5. What's interesting about tangent? What's interesting about tangent? As opposed to cosine and sine.
It isn't divided by 13.
It's not divided by 13. It's just the same, right? It's just y over x. Okay. That's cool. Alright, so we're through negative 3 comma negative 4. Oops, hey, there we go. Negative 3 comma negative 4. That puts me down here. With the theta value here. Okay. And it also puts my reference angle there. Okay. So my triangle is going to look like that. This will be my reference angle, always coming off of the horizontal. This will be 3, and this will be 4, which makes my R value equal to 5. Know your Pythagorean triples. Okay? 3, 4, 5, 6, 8, 10, 5, 12, 13, 8, 15, 17 are the 4 most common Pythagorean triples. Okay? Pythagorean triples are 3 numbers that make the Pythagorean theorem work. Okay? Right? Saves you some time, saves you some work. Okay? So R, their value is 5. Okay? Which then means that if I am going to find my theta, or my reference angle, I should say, let me restart this. I'm going to find my reference angle theta prime. That's going to be the inverse tangent of 4/3, opposite over adjacent, okay? Which gives me a theta prime value of 53.130 degrees. Since I'm living in quadrant 3, or this point lives in quadrant number 3, I take 180 degrees and I add it to that to find my actual value of theta, which would be 233.130 degrees. That's my actual theta. Okay? My cosine value of actual theta is going to be my x term divided by my r term. My sine of theta is going to be my y value from the point divided by my r value. And my tangent value is going to be my y divided by x. I just dropped the negatives because a negative divided by a negative is a positive. Logically speaking, is cosine negative in quadrant number 3? Yes. Is sine negative in quadrant number 3? Yes. Is tangent positive in quadrant number 3? Yes. Okay. So there are my 4 values that we were looking for. Okay. So, to sum up, okay, in general, if theta is through my point x comma y, and r is equal to the square root of x squared plus y squared, so basically finding what that hypotenuse is of your triangle, okay, then the sine of theta is going to be equal to y divided, whoa, tap the brakes, not that kind of y, the sine of theta will be y divided by r, which makes the cosecant of theta r divided by y. Because they're reciprocals. The cosine of theta then is going to be the x value of the point divided by r, which makes the secant r divided by x. Tangent is y divided by x. Cotangent is x divided by y. The easiest way to find theta prime is the inverse tangent of y divided by x. But when you do that, you need to drop all negative SIGN signs. Or simply put, x and y both need to be positive. Okay? For the remaining time today, now what I would like you to work on is I have a worksheet that I am going to pass out for you right here now momentarily. It is probably going to be due at some point in time. We just haven't determined if it's going to be an 85%er due or an all due case. Okay? We're in that debate right now as a pre-calculus team. Your test is on Monday on sections 4.2 and 4.3. There will be a calculator and a non-calculator part. Okay? So worksheets will be due on Monday of the ones that we do collect. Okay? You also have a formative tomorrow that you need your unit circle for. Okay? Or simply put, you can use your unit circle for it tomorrow too.